So in this video, we're going to start linking in with the web server that we've started to make. So we've got the Fasetto Word application open. Before we start growing this now, because we need to then make a web host to start talking to the web server that does the HTTP requests, we're going to start getting quite a lot of repetitive logic, not just in this application, the web application, but in general with how we do things. So what I really want to start doing now is formatting a new project that's just going to be called DNA Framework. And that's going to be a completely universal framework, kind of a helper kit of all the useful features we make that we can share between all the applications then. And ultimately, we'll have it as a package, a NuGet package that you just install. So I'm going to get started on that in this video. So it's going to be quite a long video, I suspect. And it's going to be basically shifting over to .NET Core and a .NET Standard library, and baking and really first making the whole structure and framework and getting some dependency injection in there, which out of the box isn't in .NET Core .NET Standard libraries. So you get it in ASP.NET Core by default, but you don't get it in just a library. So we're going to have to do a bit of work to effectively plumb in some dependency injection. That will remove the need for ninject in this project. And then we'll also port over the logger, which is in Fasetto Word Core at the minute. And even though we've written our own, it's nice and easy. We'll merge this into the DNA framework, just for the sake of doing that, if you will. You'll see a different way of then doing this. We'll make use of the inbuilt console and debugger loggers built into .NET Core, and we'll add our own file logger to mimic the file logger we have. So we'll do that. But this is going to be mostly a lot of kind of building of a structure that we can build on top of as we go forward. So let's just get straight into it, and you'll see where we're going from here. So one of the first things we want to do is actually make that project. So we'll just do File, New, Project. We want a .NET Standard class library. We'll chuck this in. I'll put the link to this repo in the video. So this is on my GitHub sources, and we'll just plonk it in here. We'll call it DNA. I think we'll just call it DNA. It's going to be the DNA framework, but we'll call the main project DNA. Then rename it to .framework because I want the namespace to default to DNA. So we'll just do that, and I think create directory for solution. And go, and let's see if that does what I want. I didn't want to open that like that, but never mind. Let's take a look at the folder. We have DNA. Okay, that didn't exactly work. We don't want DNA there. Let's close that down. Let's move this up, paste it into here, replace. So now we have DNA. We'll do dot. In fact, if we now just open up this solution, it's in the right folder. And then we rename this to DNA.framework, and this to DNA.framework. And then let's take a look at. So that's close to, so still not right. Save, close, DNA.framework. Maybe I should have named it DNA.framework and then done the opposite and just changed the namespace. That might have been a bit less work. So we have DNA.framework. And that should be it. That should now be a new solution in the structure that I like. And we have one class at the minute. In properties we have .NET Standards, that's fine. So let's just now go ahead and open our Fasetto Word, which is Fasetto Word, sources, Fasetto Word. And we want to reference this. One thing we'll have to do, or not have to do necessarily, but well, yeah, we will have to do it. We want to update these two to that one's already a .NET Core standard. So just a Fasetto.Word. Upgrade this to a 4.7.1 framework and click yes. If you don't have 4.7.1, then you can just go to microsoft.com/net/download, scroll down, and you'll see this 4.7.1 developer pack. Download, install that, and restart Visual Studio. And that will get you this. That just makes sure this is on the latest framework for merging in with .NET Core stuff. There's one other little issue that there's an outstanding GitHub request for. If you unload the Fasetto Word project and edit, and then in this main group here where you see, root namespace, assembly name. So inside the project group before it closes, you need to add, I think it's restore, there's no IntelliSense for it, restore project style, and that is package reference, I think. And it's basically an outstanding bug, even in the latest source right now, in the latest Visual Studio. If you don't do that, then when you build, it'll build, but when you run and you're referencing a .NET Standard 2.0 with certain packages, which is ones we'll be making use of, it complains that it can't find references. So with that done, right-click and add existing project. And we'll now go to the DNA framework, and we will reference this. As I mentioned, this will become a NuGet package, so you won't necessarily reference this in Fasetto Word shortly. We will at the moment, but then we will just be instead doing manage NuGet packages and adding, a NuGet package to this once we publish a NuGet package. So we have that. Let's try and just build now, because that looks like it's complaining. I think it just needs to restore. Yeah, so it's built. There we go. So now we have the DNA framework. We want to reference it in here. So add reference, project, and include. And now we have a reference to the DNA framework. So we can do what we like with that. So let's just make sure this application runs as well still. I didn't tell it to stop debugging, but okay. Yeah, so that still runs, it's up and going. So all we've really done there is upgraded this package, made a new project called DNA.framework. If we go to properties, assembly names DNA.framework, default namespace, change to DNA. And you'll see why as we go, because then we get a nice short namespace to make use of. So let's get started with this then. We have Control-R-G to remove that. I guess we'll start with the first thing that's mentioned is we want to kind of have a whole system. So the core entry point to this framework that your application needs to start. And in there we will hook up dependency injection, provide it through a static class, and then everything else from that point can go from there, and it'll all be dependency injected. So I'm going to rename this class. I'm going to make it static as well. And we'll just call this framework. And you'll see why I called the namespace DNA now. So when we've got the framework, we can do DNA.framework, and we're technically referencing a class. So we can access things nice and short. So for that, the main entry point into the DNA framework library. We will start with public methods. And we'll have a public static void startup. Let's do that for the minute. This will be where our application, so our application here, where we enter the application setup, this is where we'll now call dna.framework.startup. And we will set up the DNA framework. And then you can obviously remove DNA and include the namespace, and you get framework.startup. Now in this as well, you'll see we'll have something else there, but should be called at the very start of your application to configure and set up the DNA framework. So first part here, we need dependency injection. So I mentioned instead of ninject, we're going to use the built-in Microsoft one. So on the DNA framework project, right-click, manage NuGet packages, and then in browse, we'll do Microsoft.extensions. Let's have a look at that. Okay, maybe we need a bit more than that. Dependency injection. And then we want to install this one, so make sure it's the exact name, Microsoft.extensions.dependency injection. This will allow us to then use the built-in dependency injection system, if you will. We'll also rename this class to DNA, or rename this to framework rather, to match the class name. So in here now, we will have some services, and this might be familiar from the Fasetto Word website, where we make use of the service collection that gets chucked into the configure method. So a service collection is a bunch of dependencies, and this is the collection of those. So we'll have a new collection, create a new list of dependencies, and there we go. Then we will want ultimately create environment details, which we will come to, and then we will want to add configuration, which we'll do again after. We'll kind of do it in a better order than this. So the first thing in the framework, as we mentioned, is we're going to add logging, and we're going to use the built-in stuff. So we will add logging as default. So to inject a dependency, you do services dot and then add, and you can add it to a specific scope, to a singleton, or to be created every single time. So for the logger, we don't need to add specifically one of these. We can make use of, again, the built-in logger that will give us an extension. So if we jump back to here, and we do Microsoft.extensions.logging, and we install the login, this will give us the basic framework for logging that's built into, again, .NET Core. And now we should have services.addLogin, which we do. To that, we want to configure it. So we do this. Then we will add console logger. So we have the console logger like in our current application. So again, to do that, it's a package. Everything's very segmented. So Microsoft.extensions.login.console. And you can see below debug. So we'll go ahead and install debug as well, because we'll make use of the debugging one right after that. So with those two installed, we've now got add, or we should have, haven't yet, I guess. Add console, I think it just IntelliSense. Control dot, yeah. Then we want to add debug logger, options dot add debug. To do, we want to add a file logger because there isn't one built in, believe it or not. So that's where we'll make our own, which will be fun. We want to do setup loggers from configuration. We'll talk about configuration in a minute. And then we also want, which we'll see again after, the way that the built-in logger works in .NET is it always expects a type to be passed in when you're creating an instance of a logger as kind of a category name. But that can be quite annoying in the way that we want to access the log. If we're in a static method or a static class, for example, there's nothing to pass in. So we'll fix that when we see it happen. I'll show you it happen first, then we'll fix it. So that's all we're going to add right now. Create dependency injection. Add console and debug loggers, and now we will build the service provider, which is, you can think of it as the similar to the kernel in ninject. It's the thing that will actually find dependencies and provide them to you. So for that, we will need public properties. And then for the public properties, we will have public static iServiceProvider, which I think is in, yep. And this will be the provider. And then that will, in fact, we will have backing fields for that first. So this will be protected members. And we'll have protected, static, I don't think we can have protected. Private, yeah, because you can't override it. Private, private static iServiceProvider, service provider. This is the Dependency Injection service provider. And then that will publicly be accessible as a getter. So we'll just return the service provider. And then we can copy that, to be honest, same name. So now we have a provider. We need to actually get that. So in order to get a provider, you basically use a bunch of services and then you compile it into a provider. So service provider will equal the services dot build. And this is all the stuff that the ASP.NET Core website does automatically. So that's why it does configure services and passes in a collection. And then in the configure, we can then get the iService provider through injection. So that's kind of, this is what ASP.NET does behind the scenes that we're now doing manually so that we can have this ability in any application, whether it's an ASP.NET website, a .NET framework, or a .NET console, anywhere basically. So we have the provider made and built. So now we've done that, we might as well log something out. So log the startup complete. So to do that now, we want to be able to access the logger, which is now in, well, I say it's in there. It will be the, yeah, we've got the provider. So at that point, we can use the provider to get the logger, which is how you'd get anything. So let's add one more public property. And this will be an iLogger. We'll call this logger. Again, this will get a private backing field. That will be in fact, no, it won't. We don't need to store it. It's in the dependency injection. That will be provider.getService. And it will be iLogger. So it gets the default logger for the framework. So the logger has been added through iLogging. This is where you will see the error I'm talking about though. So if we were to do this manually first and do var logger equals, this will fail. So I'll put it second. What it's expecting is a category name, but you can't pass in a name, it's a generic. So you have to pass in a type. And because right now we've just got static everything, we can't really pass anything in. So we'd have to pass in just simply a type of anything. So let's just make a public class test. And then we could pass in test, and that would be the name of the log. And then we'll get that logger. And then from there, you could do logger.log, and you could write a critical message. They have helpers though to pass all that information in. So we could say log critical, and then all you have to do is put the message. So test message. And I'll build and run this and show you that this will work. This will simply get a logger, and this isn't creating, it's creating a new logger from the logger factory, which basically says just create, a logger, and then the name of where this log is associated with is going to simply be test. So if we logged critical, you can see down here now, you got critical DNA web. So you've got the console and the debug output showing. And all it's using is the name of that class as the output, which is okay in some situations where you want to create a logger and effectively pass in some details about the logger, so you know it's come from a certain class. But what if you simply, like we mentioned here, in a static, I didn't show you the actual issue as well. If you're just in a static class, or you don't want to give any details, it's just generic, that will get null. So you can't get a logger without the generic, because there is none bound to that. So to fix the issue, so we can simply get a logger from anywhere without specifying a class, which we'll still specify classes, but just so we don't have to. So this would have returned null. We'll also bind a default logger. So that's what this to-do is about. So to add to the services, so we get similar effects to this, like add logging as like a nice extension method to the services. We're going to do the same thing for our logger. So what we want to do is make a new class, and we'll call this framework extensions. We will get rid of the unused stuff. We'll have public static extension methods for the DNA framework. And in here, because the services is a service collection, we will want a public static, and then we will obviously want to return an iService collection. So iService collection control dot, and then we'll call this add default logger, and it'll be this iService collection being passed in, and that'll be services. Adds a default logger so that we can get an iLogger, a non-generic iLogger that will have the category name of DNA. So all we need to do to fix this is add a default logger services, and then the logger should be created and destroyed every time it's requested. That's the natural way of doing it. You don't want to keep it in memory. So we just simply add a transient, which means every single time you create a transient, it will be a new instance of the class that you're creating. So for that, we'll have add a transient, and we can use the provider.getService, which is the dependency injection, as we did before. So that's where we can get now the ilog factory. I didn't mean to create a file. ilogger factory rather. And that's the factory added by add logging in here. And the factory is responsible for creating loggers. So you can read all about this. I'll provide a link in the video on, how it's set up. But a factory, creates loggers, and the loggers then log out messages. So we want the factory, the default factory that we've added. And from that, we can now create a logger. So we want to create a logger, and now we can provide a string name instead of a type. So in here, we'll just say DNA. So now we've got a logger which will return just an iLogger, because it's not of a specific type, because it passed in a string. And we will simply pass that into the add transient. So this is now binding the type iLogger, because that's what this is returning, to this specific logger that we've just created. So by doing that, we can now just call provider.getService iLogger, and it will return a copy of this. It'll run this exact thing over and over, if you will, to keep creating a logger of that type. And then we return the services. So then we should be able to do .add default logger now in here. So services.add default logger. So you can see now it looks the same as how services get set up in general in .NET Core, with you use extension methods and do add and then something. So it just looks clean, like services.add default logger. It just looks like a nice way. So that should add the default logger, which now means our logger, which is this method here, so basically provider.getService iLogger, which originally returned null, should now not be null. So if we just run that to check, we should now get the logger with the DNA as the category name. So you can see we now got a logger and DNA. So we have logger info, DNA console logger, and debug logger. So it's obviously however many loggers you have, you get them all baked inside there. So now we have a default logger, as we mentioned. Let's finally log out some output. So we will have the logger dot, and then we'll do log. I wouldn't say it's trace. It's kind of informative, so it's not warning. It's not really info. It's a bit much, but we'll log it as info for now. We can always change that. DNA framework started, and if we do that and run, we should now see, there we go, DNA framework started, and DNA is the category name, information is the level, because we've done log level of information, and then finally the message. So we're getting there with that. What else am I to do? So we have something that will be useful throughout obviously any application as information about the environment. So to do that, we need to create a new class, and we will, in fact, let's make a new folder, environment, and let's make a new class, and we'll call this framework environment. And then in this class, RG to remove, public class framework environment, defaults, details about the current system environment, and we will have public properties. One of the first ones is, are we in development mode? That's always useful to know. True if we are in a development environment. And then we'll have a string that's useful called configuration. So I don't think there's a way to directly get these configuration pieces of information because they're in Visual Studio, they're not in your compiled code. So the trick to doing that is we will rely upon this value, which will be set, and you'll see how in a minute. But from that, we'll return, if we're in development, we'll say development. Otherwise, we'll say production. And I use those two names because this is what ASP.NET Core seems to do in its hosting environment. So I'm going to simply follow those so it plays nicely when used in that environment as well. So this will be the configuration of the environment, either development or production. And then from that we will have constructor, default constructor, and in here, now this is the way we're going to simply tell which one we're in. Just use a compile time directive. So if debug, then is development is true, and that's it. Otherwise, by default, end region, and if. By default, a boolean's false, so we don't need to set that. We simply set if we have a debug flag. So you can set a debug flag, or you can do the opposite, which is a release. Which again, if you notice if you take a look at our Fasetto Word web server, it seems to do the opposite. It presumes you're in debug, and it will only flag. So we set that to true by default, and then if we have a flag called release, we'll set it to false. And again, this seems to be the natural way that ASP.NET Core does it. It makes the presumption that we're always in debug environment, development environment, unless we say we're in release. So how do we get this to set to false? Well, if we change this to release, you'll see it's still highlighted out. So if you right click on Fasetto Word and do properties and go to build, and then in this conditional compilation symbol, so if we type release and save, you'll now see what you should do. This would go to showing that we're in release. I think that's just a Visual Studio not updating. Let me close and reopen. Get it right in a minute. So I'm pretty sure that's going to work. I think this is a bug in, I presume it's a bug in Visual Studio not showing that. So we'll be able to prove that if we carry on, and I'll show you in a minute the output. So that would only, basically the code in here would only run at compile time. When we compile the project, it would only run if it gets a release flag. And just to double check, oh, I know why it's not showing. It's because we're not running this specific one. We're running Fasetto Word. Fasetto Word's got the tag. So until we compile and run it through this, that directive I don't think will apply down, but it should apply down once it's compiled as a whole. So long story short, let's make use of that tag now with some environment details. So we'll also inject the environment. So first we want for environment, because we'll need to use this environment. We'll need to use this in here when we're configuring loggers and JSON things in a minute, you'll see. So I'll keep a reference to it here, make a new copy of a framework environment, which must have had the wrong namespace. Yeah, clean up the namespace. Make a new environment, and that should be all we need to do, because environment, there we go. That is how you spell environment, I believe. Yeah. It looks wrong now, I'm staring at it. So there's the environment. So if we were to simply get the environment and in the logger here, say started in and then log out, and we log out our environment dot is environment dot configuration, so it should say development or production. And again, we're not using the provider to get the environment here because we are in, I mean, we could do, we're there. So in fact, we could do, but because I want to use it up here before we compile, so the services themselves, I want to make use of that environment variable. We need to keep a reference to it here. So you can see it says development there, and you see outputs development. So if we were to change to release, we won't be able to debug, but we should still see the output. We have like minimal debugging, so we should be able to see the output at least. So continue debugging, and there you can see, if we scroll back up, framework started in production. So it successfully set that Boolean value to the correct value based on the fact that we went into release there, and that adds the value here when you go to release. So that's what's then triggering the hash if in the constructor of here. So that gets set, and that's all we're doing to detect if we're development or production. That's the only thing we do. So when you then compile to release, obviously it's baked into the code. There's nothing else you have to do. It's hard defined then in code that you're in a production environment. So we can now detect the environment. One thing we want to do is, as well as obviously us setting up our services, the whole point of dependency injection is that somebody else can set up services. So in order to do that, let's allow an optional action to be passed in, which has iConfiguration. In fact, we will need services. Oh no, the services can be added before, can be added after rather. It's more about configuration. So no, let's do that one after. Let's see. So configuration next. So a configuration is, in general, just a bunch of key value pairs, ultimately. But again, there's configuration baked into .NET Core. And you'll see it used a lot, like in the logger. The logger itself's got baked in. It can have a configuration. So if we go to here and do Microsoft.extensions.login.configuration and install this. I think that's installed. That was quicker than I thought. And then now in options, we can do add configuration, and you can see it's expecting a configuration. It says configuration can come from anywhere. It can come from hard-coded classes, it can come from JSON files, it can come from the environment. So it's like a universal way to configure anything in your application, any little class or any setup. So a configuration is simply when you do add configuration, you can pass in a configuration, but these configurations come from an actual a configuration that you make. So in order to pass in a configuration here, we need to actually make it. So in order to make the configuration, so we will now create, shall we say, create our configuration sources, I guess. And this will be configuration builder as a new configuration builder. And obviously I haven't installed that. Oh, I have. Oh, I think that package got installed with the fact that I've just installed the oh, I didn't just install that package. Oh no, I installed the login configuration package, but that must have been reliant on the configuration package. So it's because I've done it in that order. This has got installed. So let me install this explicitly as well, just to be sure that if we uninstalled login, we still have the configuration in general. So install Microsoft.extensions.configuration as well. So now we've got a configuration builder. So you make a new configuration builder, and now we do .add. And this is where you start adding your providers. So I'm going to do two providers right now. One simply going to be the environment variables, which is the variables on your computer, like the path, the home, all of the things that are in your environment variables on your machine. So again, to do that, another package, which will be configuration right there, environment variables. Microsoft Extensions configuration environment variables. Install that. Accept. And again, all these packages come by default in ASP.NET Core. That's why you don't need to keep installing them. We're going from a standard library with nothing and making them up. So now in here, we have, what did I just install? Environment variables, that's it. So now the configuration option, we should be able to do add environment variables. And we'll leave it at that for a minute. Then, as I mentioned, the caller might want to add something to your configuration as well. So to do that, we will pass in an optional action, and that will be expecting the configuration builder, so it can make use of it. And that can be configure. By default, we won't ask for it though, and then they've got the option to call. And then in order to invoke that, we can say let custom configuration happen, and we can just say configure (invoke). So basically, if they provide it, then pass in our configuration builder, and that's all we're doing. We're just literally passing in the builder at this point in our code. So this caller can do whatever he likes at this point with the builder before we move on to, adding services, because they might want to configure something, and then when we add our services, once we're finished, there's no point having passing in the services, so because they can add, well, in fact there is, I'm saying there isn't. We can add another function here for allow custom service injection, and this will be, again, we'll have another function, another action, iService provider, what shall we say this is? Services. That doesn't really go. Call it injection, I guess. Then we will need to comment on them. The action to add custom configuration to the configuration builder. The action to inject services into the service provider or service collection. So that's that. Then we'll do the same here. So injection (invoke services, and we simply pass the services, and they can do what they like with the services or not. Service collection helps if you pass in an iService collection, not a provider. So we invoke custom services, and again, we're not making use of them right now, but you'll see them used in the future. So we get the configuration, we do the custom configuration, and now once we have a configuration, we've got the builder here. The application needs to access that to do anything with it. So we can either inject the configuration into the provider, which I guess we might as well do, and then provide it. So we'll have a public static I configuration. I'm going to say configuration, and this will return provider.getService I configuration. Gets the configuration for the framework environment. So then we just need to add that now. So we have the configuration, we do the stuff there, and then we do services.add, and again we could do add login and that, but because this is a direct one, we'll show you the other way. We'll add a singleton, just one instance, and we'll pass in the actual configuration. So the configuration builder.build, and that will return, as you see, an iConfiguration root, which is castable to an iConfiguration. So now we will inject configuration into services. We will group this as well, so we'll do a region, initialize, environment. We will also inject. Did we inject the environment? We haven't provided the environment yet. Oh, I think that's what we're in the middle of. We also need to inject that. So that's really the setup. This will be environment. Keep forgetting the N. Then create the environment details, inject into services. And this will just be, again, services. What's this keep complaining about? Services.add singleton again. And this will be the instance of the environment itself. So that will be accessible by doing services, service-bar.get framework environment. So let's add that here. Public static framework environment. Provide.get service. I have to give it a name. Get service of framework environment. Gets the framework environment of this application, I guess, class. It's of this framework, of this class. I could probably do better with these comments. That'll do for now. So all of these are accessing the provider, and then there's the provider itself. So these are like shortcuts to effectively getting the injected dependencies. So that's all we're doing here. So you can do dna.framework.environment, dna.framework.logger, shorthand ways to access the the underlying things that we've injected. So we get the services, we make them. The environment we create and then inject as a singleton. Then we have configuration. So then we'll wrap that in configuration. We get the configuration builder, invoke it, and inject it. So that would end there. We then have login, which was the whole point of this initial video, if you will. That kind of ends there. So we add the default .NET Core logger. We've got to do a little to do here. We have the console, the debug, So now, in fact, we didn't finish doing the configuration. We did a little bit, but I'll breakpoint and show you the environment actually at this point. So let's just run, and I'll show you what this configuration does, that you can then use the configuration to at least see the environment variables as the first step. So we get to here. If we now hover over environment, and of course IntelliSense doesn't like doing that, so let's just at least call it. I guess we've actually got to compile the services though to get the services. So maybe if we breakpoint here, we can hover over. So you can't use dependency injection until you've obviously compiled the services. Until that point, they're not accessible. So if we've got configurations, login, and that point, it's probably wise there to pass in our configuration, which is the only other thing, which then would mean, yeah, because it's the order, isn't it? So actually, we then have that for configuration equals that, keep it as a variable, and inject it. Here we should provide that configuration, just in case our services want to make use of that in their, bit of code. So that will be a I configuration. So there we go. Now they've at least got access to that. So after that fact, once it's compiled and everything's up and ready and the service provider's there, we should be able to see the configuration through injection or not. Interesting. Does our configuration have stuff? Yep. So why did that not work? Oh, configuration root, because we've added the configuration just as, directly as a configuration. So we need to specify that it's an I configuration. Otherwise, it'll get added as the native type, which is I configuration root. So let's try that again. Now the configuration is now accessible through dependency injection. So in the configuration, you'll now see there's one provider, and it is an environment variables configuration provider. And in there we have data, and you can see all of my paths and information to my computer. Hopefully there's nothing sensitive in there, but that's all, all the information you can now get that's come from the environment. So that's one of the configuration options, if you're where you can get your information from. The other option is, so add environment variables. We also want to add AppSettingsJSON files. And this is, again, following in the ASP.NET Core's methodology, if you will. They add by default an AppSettingsJSON file that you'll see in the website, and that is then loaded into the configuration, so anywhere in the application you can make use of it. So we're just going to, again, implement that ourselves. Well, not necessarily implement, just simply copy the same behavior. So to do that, we want something called add JSON something or other. So that's not what it's called, but there we go. Microsoft extensions configuration.json. So we install this package, and don't worry about installing all these packages. These are all baked into .NET Core. It's not like we're installing external dependencies by any means, because I know, and I'm sure you guys all know, I like to have as little dependencies as possible. This is all, these are all baked into .NET Core framework, so it's kind of like you're using them anyway. They're simply not included by default in a standard library. You just have to add the ones you want. So there's no real issues here. There's no dependencies. These are all baked into what we're using anyway. So it's if you're getting stuff that isn't in the Microsoft, the .NET supply, if you will, the .NET Core. So now with that package added, there we go, add JSON file. So this add JSON file is just after a path. We can make it relative. So to make it relative, first add a path, we'll say AppSettingsJSON, and we've got an overload optional. So to make it clear, let's just say optional. we'll make this optional. I don't really care if people provide it or not. And we want to reload on change true. So we want that to, if the physical file changes, for it to reload. Add application settings JSON file. On top of that, again, ASP.NET Core has another app.json file, which makes use of, and this boils down to why I made my environment say these exact words, because ASP.NET Core does it, so we're following in suit. Again, just for compatibility mainly. What they do is have another file that's based on the environment we're in, so development or production, and it expects a file called AppSettings dot, and then the environment name .json. So AppSettings.development.json would only be settings for when you're in debug mode, if you will. So for that, we can make use of the environment.configuration, which is, yeah, that's fine as a name. So this will inject AppSettings.development.json in this instance. But in order for these to be relative paths, we need to do .setBasePath, so it knows where we're coming from. And in here we'll do directory.getCurrentDirectory, so wherever the application's been executed from. So not necessarily set base path for JSON files as the startup location of the application. Now this isn't the folder to necessarily this framework, because you can't run this framework. It's a DLL, it's a library. It needs to be included and run by, obviously, an application. So the application is going to be Fasetto.Word. So the getCurrentDirectory will be the output path of the Fasetto.Word exe. And then it's going to look for AppSettings.json to load in. And then once we do that, it'll have some settings from there as well. So once we're down here, we can do the breakpoint again. So right now, optional, if we change optional to false, we should then get it to crash because it can't find this file. And then we'll go ahead and make a file and get it so that we can, prove that it's found, basically. So if we get the configuration file was not found, you can see where it's looking. So that's correct. It's now looking for a file there. So let's go ahead and create that. So in the Fasetto Word, do add new item. And then I think they've got a JSON file. Do a JSON file and we'll call it AppSettings.json. And where's my mouse gone? Come on, mouse, there we go. So here's a blank JSON file. So let's add what would be the configuration for the built-in login, because that's what we're doing in this video. So we have a login, and inside that we have include scopes, I think it is, and that'll be false, and log level. So the level at which we want to start outputting, the default level, we want to output warnings or above. Warning, I think it is. So this is a structure, and I'll provide a link in the video to where you read up on the built-in logger, so you know what values go in here, what you can do with this configuration. Browser says then we can add our own configurations, like my settings, and then you can have whatever values in here, and then in your own projects and own parts of this as we build it up, you can make use of the settings from a settings file that the user can change. And you can also get it from any other source. You can pass it in through the environment variables. And then that's where this configuration starts being useful, because you can provide the same thing when you're saying services.getConfiguration. And then you simply get some details, like you want to know the, say, connection string to an SQL database. That could come from the app settings. It could come from hard-coded. It could be passed in through the environment variables. And they'll all merge together and take precedence and, merge in. So your application, the thing doing the SQL connection, doesn't need to be concerned about where that connection is coming from. It can come from any one of all these. So again, we'll make use of this in future videos. But in essence, you can see it's just providing, it's a configuration provider that simply provides a bunch of values. So we have that file, and it's not optional, so it'll have to find it. So if we run it now, it should find that file. It shouldn't crash this time because the file is there and exists. and it still crashes. Oh yeah, I know why. Because we're not in a web application where content automatically goes to the output folder or can be found. So we want to copy of newer, basically, in there. And this means it'll then get outputted to the bin folder. So there we compile, we get that. If we now hover over configuration, we should see a third one, 3, and now we have, or rather 2 more. You got the JSON provider for the AppSettingsJSON, and you've got one which I presume should be AppSettingsDevelopment.json. So there you go, it's trying to find the 2. In there's a file provider, which is the JSON file provider. And so from this now, you can see this file has then included login, include scopes, login, log level default. So the values are in there to be accessible. If your application wants to access the configurations directly, there's multiple ways. One of them is through configuration.getSection, and we can say get section called login in the configuration. And then say let's do get children. Let's just get all the inner parts. Just do like that. So this is what the code inside the logger will do. If there's a configuration, it'll say, try and get me the login section and then get the children. And in there, we can see we have include scopes, and we've got the log level, and then there's no value because you have to get the children, which has then got the default log level. So that's just a really quick overview of what configurations are. And again, they'll be used heavily going forward, so you'll see how they're used and make more use of them. So now we've got the environment, the configurations in there. We can now set up the logger to use the configurations. And again, because we're using the built-in logger, it already supports it. So we just do options.add configuration. And that should be it. I think it's actually after the configuration though. So we can just provide it through either configuration.getSection, which is, well, in fact, that's what we'll have to do because there's a configuration. Configuration.getSection, like we just said, logging, and that's all it's after. It's after the specific section. It doesn't care about the internals because it's expecting effectively this inner detail. So you can technically call this whatever you like, but again, ASP.NET calls it login, so we'll stick with that name. So now we have a configuration for the login. So the logger should now start listening to our settings. So if we run this and we step to here, we should get a log output, which I don't see yet. Maybe if I run it, it'll show up. There we go. So information, no, that's our other logger. We have, oh, I know why. It shows it's working. We've said to log only warnings or errors, basically anything above a warning, and we're logging information. So if we log critical, which is the most vital message, it should always get output unless you're saying to not output anything. We should now get the log output. So there you go, log critical. So you can tell that that is now reading the configuration correctly. And then just to really prove it, if you will, to test it, let's open up settings and do none as the value for the log level. So now it shouldn't even print out the critical, which you can see nothing's printed out. And then to, I guess, quickly test the AppSettingsDevelopment one, if we do copy and paste, do AppSettingsDevelopment.json, these, I don't think, can you drag that in? No, so you can't get that behavior like you do in the web. These settings will accumulate and combine, if you will. So they don't override each other unless you've got the same value, then they will override. So in the development environment, let's set it to, well, let's leave it as warning, I guess, or let's forcefully set it to, which way shall we do this? No, let's do the other way around. Let's do production. So in the production environment, let's change it to none. So when we run now through, where are we? Breakpoint. We run this in debug, and we should get the output, critical. We run it through release, and it should read the AppSettingsProduction.json, where we told it to not output anything, and we should not see DNA framework started output. So nothing there. And then again, to double check, change that back to warning, say, and change the default to none. So by default, we wouldn't output anywhere, but then in production we output. So we kind of flip the logic a bit. And there you can see now we get the output of logging out. And if we change back to debug, because it won't then read production as warning, the default will be none. So we shouldn't get an output this time. So you can see that's basically loading. There you go, no output. That's loading the configurations. So for now, I don't really care about custom, differences in debug versus standard. And I'll change this back to warning. I will, in fact, if we find the fundamentals logging ASP.NET Core, I think this is it. So this is the page I'm on about that will give you can see here's the way that ASP.NET Core does it. Very similar to what we've just done, apart from they require, it's optional there as well. So we're doing very similar, like I say, to the kind of setup that .NET, the ASP.NET does by default. What I'm looking for in here, though, is the log level. So you can read through this. I'll put the list in. We get log level. So here's the options we can have. So none is obviously none. Critical, debug, trace, I think, is everything. So I think that's the lowest one. We can, in fact, I don't know why I'm doing that. The easiest way is to just type log level. So log level, press F12, ta-da, there's the enum. So it's order of priority, so none is obviously the high, so it's anything with a higher number than that, which is nothing, would get logged. So if we do trace, that means it'll log everything. So I'm going to set the default logger right now to log everything with trace. And I'll provide the link to that read up on the logger if you want to read more about it. So now we should log everything by default in our application. We've got the configuration set up, the environment all done, initialize done, login, right, file logger we've got to do. So let's just finish wrapping this up. Custom injection, so region, services, or custom services and building, I guess. So there we go, that's all that bit done. So this is, for the most part, done, if you will. We've got the framework ready, up and running. We have an environment, we have the basic setup, and now we have a provider that can replace ninject. So the last step I want to do in this video, and unfortunately this is where most of the work actually is let's make a file logger. So where do we go to get that started? Right, let's start with a folder. This will be logging, I guess. Then in here, we'll do file. Right, so the way the logger works, and I have to think this through because there's a lot of classes. We have a log provider, I think is the first stage. So we'll have a file logger provider. Clean up that. Get rid of the surplus namespace. We have public class file logger provider. That has to override an ilog provider. iLogger provider. I keep forgetting. Everything's a logger. Control dot to implement the interface. Right, so we have to, let's comment this. Provides the ability to log to file. iLogger provider implementation. So we have create logger. So as I mentioned, this logger is responsible for actually producing loggers of this specific type. So a file logger provider. So that's how we'll generate our logger. This thing spits out, whatever loggers, because you can have more than one. You can be logging to 7 files. So the responsibility of this provider is to, when the log system itself, the log factory, wants to get a file logger, the factory asks the provider to generate a logger. So there's the iLog factory or iLogger factory that talks to the iLogger providers. The iLogger providers generate the iLoggers. So it's, again, you can read all this up on that link. So the first step is really the provider for us, a custom provider. So this will be protected members because we'll need some. And we'll start with a protected read-only. One thing you want to do with all your loggers is have a configuration. So we will make another file. I know we're in the middle of this one, but this will be file logger configuration. Let's get the simple stuff out of the way first. RG to remove public class file. Oh, did not name that file correctly. Public class file logger configuration. The configuration for and we don't have it yet, but it will be called file logger. So the file logger configuration will have public properties. It'll only ever have properties, but we'll still make a region. You never know. Public log level. So don't really need to configure much. So we'll just make a log level and get set. And the default one we'll do again is trace. Will log everything out. The level of log that should be written, or that should be processed, let's say. Let's do one more, because our original logger, which is here, we log the time. So let's also pass in the log time. So, or rather, if we want to log the time, so this will be log time. And again, by default, we'll say true. Whether to log the time or not. I'm going to log the time as part of the message. So that's just a set of options for any file logger that we want to create. So the log level and then simply log time. So that's made now. That's done. We can get back to the provider. So whenever the provider is created, because this needs to spit out a bunch of loggers, it needs to have that configuration in order to know what configuration to use for the loggers. So we have a file logger configuration, and this will be the configuration. Configuration to use when creating loggers. And we will also have a protected read-only. We want to keep a list of all the loggers we've already created, so that when, in fact, when we do create logger, we don't want to keep recreating the same logger if the path is the same, if you will, or if the category name is the same. It depends on how we do this. So if we do a concurrent dictionary to keep it thread safe, and we'll have a string, which will be the path, and we'll have, in fact, we might have to change a few things up, but that'll do for now. We'll have the actual file logger, which we also haven't got yet. So jumping the gun slightly, let's make file logger class, clean up, remove the additional. Public class file logger will implement iLogger, which is the final step. A logger that writes the logs to file. And implement that interface. Might as well quickly write this. Begin scope. We're not going to scope this. It's writing to file, so we don't need a scope. Is enabled. We'll deal with in a minute. Yeah, okay, screw that. We'll come back to that. So we have loggers. Make a new list up to keep track of the loggers we've already created. Keeps track of the loggers already created. Okay, so in dispose, all we need to do is clear the list. And in create loggers, we have category name. For now, we'll just do it based on category name, but I will likely change this to, in fact, no, that's probably right. Based on category name, we have a logger, because the logger can add a file. Yeah, that's actually fine. So do mloggers.get or add is a useful function here. So it'll either return the logger for that key. If not, then it will create one, which is that way around. So it always creates a new one. So that will be name, new file logger, and then name and configuration. So yet we don't have a path here. We'll figure that one out after. And now we can, yeah, we haven't passed that in yet. In fact, this is where we want the path. Where are we going to get the path from? I think it's going to have to come through the configuration for the logger. Yeah, we're going to change this, but I'm not sure yet. We'll probably reverse backwards to figure this one out. But the logger will expect, as you can see here, it's baked into the provider. You're meant to provide a logger per category. That's kind of how this works. It's hard baked in. But the issue we have is the file logger is logging per file. We really want the file logger, if we can, to be writing and be the only thing writing to a file at a time. So I think what we're going to have to do is there'll be multiple instances of file logger, and each file logger will log to the same file based on the configuration, because the configuration is what will be passed in. File logger. File logger. How have we got two file loggers? Oh, because that's the other file logger we made called exactly the same. I was getting confused there. Yeah, so let me just have a little think on this. File loggers are not scoped. So this is always null. Just put a comment. The is unable to come back to again. Back to the provider. So creates a file logger based on the category name, the specific or the category name of this logger. Get or create the logger for this category. So that's going to work. File logger. Right, so the logger is going to need the configuration passed in each time as a variable. The configuration then that's going to be added when we do add file will need to have the path. We know that much now. So this will be public string file path. The path to write to. So we have the logger. Let's also go ahead and add yet another class, and this will be file logger extensions. And let's start working this backwards, so we can kind of go from what we want it to do and want it to look like to what it really does. So extension methods for the file logger. And then this will have, just like the other ones, public static. And this time it's going to be I think it's I logging for once, builder. Yep. And this will be add file, we'll call it. We'll want I logging builder, the builder, and we also expect a path of where to log to. As a new file logger to the specific path. The log builder to add to. The path where to write to. So this will want to add file provider, which is what we should be adding. File log provider to builder. That's in fact, it's making a lot more sense doing it this way around now, so I can visualize it. So we do add provider to add a new logger. This isn't asking for a logger provider, so we'll pass in a new file logger provider, which now makes sense. So now what we clearly need here is to pass in the path, which is the only thing we really care about. So we know now that, let's finish that, return the builder. The file logger provider will want a constructor. So that will be here. In fact, leave that out a minute. Default constructor. Path to log to. There we go. And now this wants to be in. Where did the configuration get set? It doesn't. So the configuration can be passed in to the add file, I guess. And if not, then we can use a default one. And again, we'll update this, probably not in this video, but we'll update this to pull in from the configuration sources, like we, from the file sources and things. But for now, I'm not going to bother for the moment. File log configuration equals new, and we'll just make a default one. Can you do that? Compile time constant. Okay, so instead of that, we'll do null, passed in, create default configuration if not provided. And we'll create a new configuration. And if we wanted to configure it, we could set the log level and whether to log time, but we'll leave all that as default. So we'll just literally create one. Then we'll add the provider. We'll now update the configuration. Set path. In fact, do we need to set the path in there because we're passing it into the provider? So no, we don't. The configuration doesn't need the file path in. Which kind of makes sense again because you're configuring it in the path there. So the path there, and the log provider then wants to have the configuration passed in, I'd say. So now the file logger provider can have file logger configuration, and that will now finally boil down to the configuration being set. And we have the path, so we need to also store the path. There we go, it's starting to come together now. The configuration to use. Right, so we pass in the configuration, the path from, if we jump back up, we add a file. You want it to be the path you go to and the set configuration. If the configuration is null, you set it, then you pass the path and the configuration. So that should be our add file function done. And it's all commented. So let's step back up further and let's get this actually added. So that'll be in the framework login now, the final to do in here, add the file logger. So now we should have options.add file, which is our function, which is now expecting a path. So let's do, and this is the thing with until we add the configuration, we won't have the base path that's in the configuration that we set here. So we'll make use of the configuration, but like I say, probably not in this video, just because of the time. We'll split that up and we'll make use of that in the next one. So for now, we'll just say log.txt, and we'll get it right locally anyway by default, and just ignore the base path and do that in the next video. So we've got that, and then it's expecting a configuration if we leave it as null. So now it's as easy as saying add a logger to log, and we can also add, and we might as well, just for prove that this is multiple. You can add 2 logs, so it gets logged to the same place. So we've got this is done, this is fine. So this boils down to the log provider extensions, which then basically adds a provider, a file logger provider, which has now got the path and the configuration. So that's that done. The provider gets that information and sets it in there. And when it's implemented, it will now be expected to create a logger based on the category name and clear the list when done. So that is now complaining because the file logger. So now when we make a file logger, it needs to know the category name because that's specific to each logger. So that will be category name. And, or is that what's passed in? Oh yeah, that's what's passed in anyway. So the category name will get passed in. So this is the category name here. It's just that when it gets created, it will be passed through this expression. And it will need the configuration. It will also need the path. So it will need the name, the path, the configuration. So now if we go to the file logger, the functions are there. We'll have constructor, we'll have string category name, string file path, and file logger configuration. We'll name them category, the configuration to use, come on, the file path to write to. Store them all in protected members. Protected string category name, the category to write, category for this logger, protected string file path to write to, protected string can't attack today, been a long day. The configuration to use. There we go. Set all those. Set properties or set members. File particles. File path. Nearly there. Come on. Right. So constructor gets the information it needs. The logger that gets created, we don't use a scope. Enabled if the log level is the same or greater than the configuration. The log level to check against. So this is basically saying if we log a critical message, or if we log a warning message using log warning, then this will come in as log warning. And as we know from here, you can clearly see it's going in order of precedence. So if we say we want to log warnings, we'd expect to log warnings, errors, critical, and obviously none's nothing, so anything below that. If you say you want to log trace, which is like everything, you'd expect everything here. So quite simply, the check is to say if the log level is, there or greater than, if you will. So it's anything above it. So will be enabled if the log level of the message that it's checking against is equal to or greater than the configuration's log level. Why has that not got it? What have I done wrong here? Oh, I've done a string. Why did I do a string? And why did that not complain? Unless it did and I wasn't even looking. So configuration log level. So what are you complaining about now? Cannot convert Lambda to Boolean. Return log levels. Great. Oh, it thinks it's a lambda now. That's not what I'm after. That's not what I'm doing. Oh, yep. You can tell it's getting a long day. I've done equals greater than, not greater than or equals to. Right. So that will be enabled. Enabled if the log level is greater or equal to what we want to log. And then it's finally going to boil down to actually logging the message. Logs the message to file. The details of the message, the log level, the ID, the T state is a type of state. The type of the details of the message. State is the details of the message. Any exception to log, and the formatter for converting the state and exception to a message string. Right then, so from here, first thing we need to do is make sure we should log. If we should not log, so if not is enabled, the log level of this message, then return. So that's just making sure we should log. Because we want to clone our file logger in the behavior, we can kind of copy our log for the most part. Get the current date time, prepend the time to the log of desired. So here now, the log time will come from configuration. If we should log the time. If we want to log the time, then the string that we prepend has the time. So this is the same as our other logger. And now this is the difference, right? The message. So the message equals, and then it's going to be the time log string, the message we don't have right now, and then a new line, and then all this to file, which we don't care about. We also don't need to do a new line in this case. In fact, we will have to because we're writing to a file. So we'll get the message, and then we will do file dot write or append all text. The path is the mfile path, contents is message. And then we'll obviously have to lock this because we could have multiple. So what we will have is a static lock for the file logger. So we can do protected I think you can't have protected, I keep forgetting. Protected static concurrent dictionary of strings and object. In fact, we or do we just do an async away to lock? Debatable, because we don't actually need any info and we're going to dispose of, so we don't actually need a concurrent dictionary. We need a concurrent, is concurrent bag just a thing? Yep, so we use a concurrent bag. Sounds awesome. So this is just a thread safe list, basically. I don't know why they don't call it concurrent list, they just call it concurrent bag. I presume that'll have what we need. So this will be file locks. And let's just check if this is good before we comment. And let's try and actually lock. So we would do and I think we can do a lock, so there's no async here, which is good. So it would be lock, file locks. Let's see what we've got on here. Try peek, try take, try no. That's not what we want. Don't want a concurrent bag. Concurrent queue, concurrent stack. Don't want a stack. Don't want a queue. Okay, maybe they don't do it. Maybe we'll have to use a concurrent dictionary just for the sake of trying to do that. Or we just drop back down to our list of... Oh, what am I saying? We've got an async awaiter already. We could make use of an async awaiter. Mind you, no, there's not that either. Hang on a minute. No, let me think this through. I think we do need a dictionary because we need the object to lock. So I was right in the first place. I think. I'm going to comment. I'm pretty confident on this. A list of file locks based on path. Now the only thing here is if you added a path which is the same, but one's relative, one's absolute, or one's in a different format, so we'd have to fully normalize, standardize, and get absolute path and blah, blah, blah. So I think we'll do that anyway. As enabled as done. Message here. For now, just to stop this moaning about message. Output. Message equals nothing for now. To do. Right, so the where did that go? What? Come on, keyboard, what's going on? Right, so what we need here then, back to the original one, is file locks dot get or add, I think. So that will safely get an object. So this will be var file lock equals, and then before that we need to normalize and absolute the path. So to normalize, we'll just uppercase it, and to get the absolute path, normalized path equals the file path dot to upper to normalize it dot. In fact, no, do it the other way around. Actually, you have to do it the other way around. The path dot get full path. So that will resolve based on the. What will that do? Yeah, that will resolve it to an absolute path based on the current environment. So because we're not making use of that base path right now, which we'll make a note of, to do make use of configuration base path. But for now, we're not going to bother. So that will resolve it to an absolute URL, and then we'll do to upper, which is fine for our normalization. So finally, we have a normalized path that should be the same for any single specific file. We want to lock based on that, and if we don't have it, then we will expect to be path. We don't really care, just a new object. So if there isn't one, just create a new object. So I think get the file lock based on the absolute path. There's a lot of thinking going on here, whether it's working or not. So we'll finally get the lock, and then we'll just simply do a lock on the file lock. So I believe, and I'm not even going to bother testing, I can leave that to you guys. I think this will be thread safe. Presuming that nothing outside of our application's got that file locked, which I don't really care about right now. And then finally, write the message to the file. Again, we'll add some kind of wrap. Well, I say we'll add some wrapping on logging. This is the logger, so if the logger crashes, I'm not sure where we'll throw the message to, but we will add that into this system as we go anyway. So we've got the file, so now it's the message. So this boils down to, you might say here, where the hell's the message? Well, the message is actually in the state, and that is because you can pass in a number of arguments, and the formatter is then responsible for trying to format that message. So we can have basically custom formatted messages is what happens. So I'll kind of explain that afterwards, but for now the default way to get the message is just to do formatter, and then pass in the state and pass in the exception that's provided. And get the formatted message string. So by default, that will come out as the message. Then we're going to edit that to add our other thing that we have in our existing logger that we also want to maintain somewhere, which is the lovely ability of having this information in. So where the origin was. So we want to maintain that in ours, which we will. So at first, let's just get this thing logged into file. With time, I guess, at least, which is an option. So we have a file logger. It all is roughly in there. It should boil down to getting to here. That passes through. So I think we're in a fairly good position now to maybe run this thing. Dare we? Add debugger. So add logger. Let's just start with one logger. Let's play it a bit safe. And let's see. Yeah, let's press F5. Let's see what happens. And that's not a good start. So because we've called ours file logger, we just need to keep the original file logger in our application set to the old one for now until we fully replace it. Ooh, that's a very good start. So we're at least in the file logger log message. Should we log? Apparently yes. Current time is now. Log's time string should be the same, so it's the time now. The formatter, which is the funny thing where you'll say it's just got this weird list, will basically boil back down to the message we said to log. So the output message, which should stay the same, is now looking like what we originally wanted to output, with the exception of we don't have the caller information yet, which we'll add back in. File path is hopefully log, so let's see where this resolves to. So this will resolve to our output folder, which is good. That's kind of where we want to be, at least for now. So we will be in bin debug. There's apparently already a log file. How's that worked? Because our logger, it already logs to a file. We've called that exact same thing. Let me just stop this a minute. Our existing file logger that we made logs to log.txt. So yeah, the core one is old logger now, or old log. So if we just delete open folder, bin debug log, let's get rid of that log. So now the old logger, as it's now called old log, will create an old log, but this one now should create a log that's going to go to log. Oh, there's a point. We should actually use normalized path for that as well. Stop it once more. We get all the way into here. We know we do now. And then we should log to the file. So we have nothing right now. And then we write, and we have log.txt in capital letters. So we don't want to have the log in capital letters, but there's the file, so that worked. So let's just do the full path first. Get absolute path. And file path. Can we do that? In fact, we could do that. We could do that when we construct it, because we get the path. So normalize it there, or rather absolute path it there, then set it. And then in here we can make use of the original, and only in here do we care about the normalized path. In fact, we'll, yeah. There we go. So now that we'll have a lowercase name, and if we unhook that, don't care about that now, and we watch here, we should end up with a log text file in the original name that we didn't put a breakpoint there. There we go. So now we have a log.txt that says it's starting. Now we need, hang about, where's the time? I just noticed that didn't have the time. And I swear that's did have the time. Oh, I've logged the message, not the output, which includes our extra stuff. The message is the original log message. So we should get up and running. And the log now has that with no new line, because why? Did I forget something else? No, okay. That should have a new line. Why are we not getting new lines? That one did. Maybe we delete, start again. First message. So there's a new line. Okay. Second message. Maybe it was when I originally did the first log, I didn't have I outputted the wrong thing, so there was no new line ready. There we go. So that's the logger, 90% done, back to effectively where we were, but baked into this core library. So the last thing here now is to add the caller member info here, so we can log that. So this will be not a massive amount of work, so I'll show you how to do it with a custom formatter. So we'll start with a general class in the login, not inside the file, and just call this logger extensions, because this is extensions in general. Remove all the crap. Again, public static class. Extensions for iLogger. So I just found the namespace. And extensions for iLogger. Loggers. In here, or rather, let's show you where it happens first. Framework. So this log critical, if you press F12, is, funnily enough, they've got one called logger extensions, so have we. In fact, that will see if it works. I think it will. I think it'll just merge in. So all they've done is overridden a bunch of things to pass in default stuff. I don't need to go into this detail. Again, this is something you can go into on the actual .NET Core logger documentation. But these are shortcuts to log messages with critical, debug, error information trace, and warning levels. So all you want to do, I'll only do one in this video, then I'll do the rest offline. Otherwise you'll be bored of me doing all of these all over again. But the thing we need, when you need to get this caller information at the point of writing the log. So when you call log, we need this in. So if we copy this, this information has to come at the point of logging. So it has to come from here. So we'll use an extension method, and we will, in fact, I close that class. I'll need to copy that out again. If we go to here, say, let's do the critical one, and I will just copy all of that and paste it into our extension. And then in here, we can do the same thing again, which is logger.logCritical. This would cause an infinite loop, but obviously it's not going to be the case. We'd pass in the message and the args. So that would call, if we did log critical, we'll call it source. I can't think of another name really, because we want to include the source of where it come from. If we go to the, I knew it. Did I close it down again? Caller member. That one. So we want to copy these. These need to be included in this part. So we'll have to paste them before the params, because that's an infinitely long list. We'll do the logger, the message, then we want the specifics that we're on about, and then finally that. Include the compiler services. Logs a critical message, including the source of the log logger, the message, the caller's member function name, the source code file path, the line number of the caller. And the additional arguments. Now, because we have, or we want to, what we're going to do is prepend these three pieces of info into the parameters that can also get passed in as like an additional. So what we want to do with that is append to this list, because the params simply means an unlimited number of objects can be passed in. But if we then try to do the parameters here, we need to pass it all in one object array. We can't do origin. We could do origin, file path, line number, and then args, but what that'll have the result in doing is actually, in fact, why is that complaining? Line number. What that'll end up doing is actually passing an array of 4 objects, and the 4th one's an inner array of objects. So we have to combine this list. So we'll just make a little helper for this, and we'll give a new folder called array extensions. We'll just call it array, and the class can be called array extensions. Clean up, remove public static class, extension methods for arrays. In here we'll have a public static, we want an array of anything, and we want to append, say, to one side. So the array is the source input, and then we want a bunch of params, which is also an array of anything, and that's to add. So that looks kind of funky. That will append the given objects to the original source array. The type of array, the original array of values, the values to append to the source. And that will then do, we'll say get a list, so we can append to it. New list of T, and because we want to append, which means go at the end, create a list of the original items. Now we want to append the new items, so we just do list dot add range, and it's to add, so they go at the end of the array, return the new array, and that will be list dot to array. So that will basically just simply take 2 object arrays, or in this case 2 of any array, because I've made it a generic, so simply 2 of any type of array, and it will chuck these at the end and return a new array. Then we'll do the opposite as well, in case we need it. Prepend the given objects to the original source. In fact, that's the one we will be using anyway. So this will be prepend source to add. So in this case, you flip it round. You do the to add first, and then you add the source. So create a new list of the new items and append the source items. So that will then prepend. So now we should be able to do, because it's an extension method, anything that's an array, we should be able to dot append and dot prepend, is the theory. So finally, if we call log critical source now, all we've done is copy and paste to the original log critical, but we've prepended where the caller is. Instead of doing these 3 things separately, we need to pass in the args, and now we should be able to do dot prepend. There we go, and just pass in them just like that. So that should then simply combine args and chuck these 3 at the front. So that's step 1 accomplished. So now if we did log critical source, we do nothing different, we just call it from here. they get passed in as arguments. And in the file logger, I don't think we'll see that because I don't know whether IntelliSense will show that. So, can we see state? Come on. No, so I can't really see anything in this kind of view here because of the fact that we're passing it to a basic formatter. So what we need to do now is actually provide the formatter. So to do that, in fact, we can't then use this override because this takes away the ability to pass in. I believe. Yeah, so we can't pass in a formatter to this log critical. So what we'll have to do is drop back to log and just call the original, which this log is basically our call, like this exact call. And we're going to provide a new formatter. So that also means we need to provide an event ID and an exception. And I think that's it. So let's go to the message. We'll have an event ID, which is event ID, and we'll allow them to pass it in, but by default we'll just make a new one. So just a generic event, we don't use it anyway. Same with exception, we'll allow them to pass it, but it's not required, so it kind of keeps it the same. So now we can do in the log, we pass the message, pass the event ID, pass the state. Its state is these. Yeah, I can pass them all in case we need more. So I'm pretty sure that's the state. Then the exception is the exception. And finally, now we can provide a logger, a formatter. So we'll make a formatter. So for that, we will make a new class. I know there's lots of classes here, and we'll call the source or logger source formatter. And that's then able to be used and passed in. So for this, we'll have public class logger source formatter. Static. Or can we... Yeah, I think we can pass it in as a method. Public static string, because it needs a string back. I'll just call it format. We've got the state, and we have exception, which gets passed in, I believe. Yeah, a state and exception returns a string. So if we do that, just return test for now. And we could always breakpoint there as well. We can now pass in to our log message the source formatter.format, the function. Yep, cool. So this has been very long-winded. Concatenate string to log level. Oh yeah, the log level we also need to provide because we're overriding it. So critical, then the message. Oh, that's not the message. The message needs to be part of that because that's part of the state. So event ID, arguments is going to have the original, the file path, the line number, then the message, and then whatever extra arguments were passed in by default. So we'll have this order of priority. We'll have, when we come to use the formatter, you'll see the index 0 will be the origin, then the file path, then the line number, then the message. So from that, we can then finally combine this thing into a message that we want to display. So now if we call log critical source, it will call the logger.log directly, pass in all the values, and also tell it to use our formatter. So then when we do formatter here, it's calling our formatter because that's what we've passed in. So if all this goes to plan, we should end up with a message that just says test, but all the information we need should be there that we can then format a string. So we've hit here, interestingly, before we even hit here. I guess it's being formatted for us somewhere else first. You can see we've got the 4 objects. Startup is the class name. There's the source code, there's the line number, and there's the message, which is what we wanted, and we have no exception. Then we have same again. So that must have been the internal stuff getting called somewhere first. Or, oh no, what it was is the debug and console log. So you can see it's outputted the message test. So here the formatter we can see as our formatter. We'll hit that again. And now we've got message test, and the output would be time and test. So the only thing we need to do now is tweak our formatter to actually format. So format the message including the source information, pull out of the state. The state information about the log. And that's the cool thing about doing this kind of, I know it seems like a hell of a lot of work, but doing this formatter means we can pass in custom information in logs of any amount, of any kind, of any type, and then format them specifically and still have them output as a string to a logger. So it's really powerful. Some people don't like that. I really like it. So let's first get the values from the state. And that will be, the message is 4. The origin is the first one. The file path is the second one. The line number is the third one. Message fourth, mistake there, fourth one. So get the values, get any exception message. And that would be exception question mark, and just use get message or to string. And then we will return, if there is an exception, actually, we will do, I just want a new line if we're doing the exception message. We can dump it at the end, but kind of want a new line. So we'll actually do exception message equals string.empty, or rather, exception is that new line if we have exception. If exception is equal to null, message plus equals system.environment new line. I think that's the cleanest way I can think of doing it. So we have the message, we have the exception, we have all the details we want. Now we just want to format it just the same as we did in our original logger. See if I can remember, there we go. So we copy that info and we paste here, return the message, then the, can't do the message there. We'll add it to the exception message. We have the message, then we have path.getFileName of the file path. What's wrong with that? Oh, these are all objects. We need to cast them to the known types. So that'll be string, that'll be an integer, but we actually don't care, but let's convert them anyway. I think that's just integer, not a long. Yeah, if you've got a file, source code file that needs a long, then you're in trouble. That will be string, message is string. So that's what we're expecting. We could do as to be nulls, but I prefer it to kind of crash in a sense that if you've casted wrong or passed the wrong thing in, you get an exception instead of just a null value. Format the message string. So you'll have the message. You'll then have exactly what we had before, the file path, the origin, the line number. So let's add formats a message when the caller's source information is provided first in the arguments. That's all done, that's passed in. So now we should get an exception message that's exactly the same as our previous logger, but now baked into .NET Core. So you've got critical DNA framework started, and then you can see it's called from framework.cs startup line 130. And that's perfect. So now we have the message, which is there. We have the output, which will then prepend the time based on our configuration saying we want the time, which we added in, well, we didn't add, by default it went to the logger, the configuration got created new, and that by default we append the time. So we could disable that if we wanted. It logs to the log file, and we know that already works. So now when we run, we finally have a log file that looked just like we did 2 hours ago. But now it's baked into .NET, so it's cool. So there we go. That was a really useful 2-hour video of how to do what we already did. But on a serious note, this is kind of the building blocks for where we need to go. So this looks like a lot of what we've done is, let's also check we can write to 2 logs. This is now a framework that I'm going to, obviously, again, make open source so everybody can make use of it and see it. And there we go, 2 log files. I will also start using this everywhere. So this DNA framework will be used in everything, not just Fasetto Word. This will start getting imported into the DNA web. It'll be used in Fasetto Word. It'll be used in the server. So this framework, everything we start moving into here, will be completely universal, like just used everywhere for anything. So that's kind of the point of this, because I make so many projects and there's so much I end up redoing and remaking. And it's used like async. I use this async await everywhere, absolutely everywhere. So this await will end up in the framework. And then once we've got this a little bit mature, or maybe even straight away, I'll make this a NuGet package and show you how to do that in a video. And then you can just right click on any project, manage, and just install DNA framework. And then in your main startup project, which in here is here, you just call framework.startup. And this will add all the logging, all the file management, all the error exceptions. You'll gain all the dependency injection, the async stuff, anything that's of use, that I always use and I know is going to be useful everywhere, will now be in this framework. Once we've done that, this Fasetto.word.core should then only contain stuff that's specific to our core Fasetto Word and server application. So it starts to make this much cleaner and easier to see. So after this now, I will fully integrate this framework into Fasetto Word, clean up Word core, move it all into framework where we can, and push it as a NuGet package. And then from there, we'll finally make the Fasetto Word talk to the Fasetto Word server through a web client. And the reason I wanted to do this is because that web client is, again, something that's very useful for any modern app, that we can now talk to a RESTful server or an API server or anything through HTTP. So I didn't want to then do all the work and make HTTP in this video in Fasetto Word Core and then not have that ability in any other application we make. So I kind of want to make this the focus of anything that's universal. So hopefully this video was useful. You might not understand what we've done as such here, but in essence what we've just done is added the built-in .NET Core Dependency Injection service, which is ultimately this provider, now made that into this universal platform that we can consume in this. And that means we can get rid of ninject and we're back down to one less reference, if you will, one less external non-Microsoft reference that we don't need. plus now this dependency injection will work anywhere that .NET Core works. On top of that, we then merged in the file logger, and instead of just having our completely separate file logging system, we're blending in with the built-in logger, which is more supported for, third-party applications or tools that consume .NET Core, and they're going to expect the logging to be, they're going to use the inbuilt logging. So now we've added a file logger into that inbuilt logging. So hopefully this was useful. Again, any comments, questions, let me know, and I'll see you soon.